Welcome back to week 5 of the Containment Seal mini-series. This week we consider safety considerations surrounding containment seals. Following the previous week's videos, I think we all now understand that largely containment seals are often misapplied and missupported, and due to this the integrity of the containment seal is unknown in service from the moment the machinery is started. Especially given the fact that inboard seals on best-in-class process plants are exceeding the running hours which API 682 recommended as being the running life of the containment seal, in some cases by a factor of 3 or 4 times. However, there is a growing industry understanding and realisation that containment seals are not as safe as originally perceived, and best-in-class operators are reviewing their fleets and upgrading to differing piping plans, but for those that don't upgrade, the question of integrity testing has been raised. Currently, there are no API or industry guidelines for containment seal in situ integrity testing. Chris Phone and Pete Bowden were very well-respected engineers, employed by one of AESSEAL's major competitors. These gentlemen will be widely known to most who have been in the seal industry in the last 25 to 30 years. Their technical paper delivered at the Pump Users Symposium in 2002 recommended a weekly £25 per square inch static test on the containment seal chamber to verify the integrity of the seal to hold under pressure. Unfortunately, this is not always practical, and hardly anybody ever does this. We have urged customers who use containment seals without operating a Plan 72 to periodically test the containment seal for integrity. A test procedure has been authored and is freely available from the AESSEAL website, aesseal.com, if any viewers wish to implement this. The example on the graphic was of a user who had a 75% failure rate of their installed base, with some seals not ever being operated. The observation made by this particular customer was the amount of valving required to successfully test it and how awkward it was to install, together with the nitrogen bottle and regulator needed to pressurize the seal to the right pressure. In addition, the leakage collection vessel could not be fully isolated as there was no block valve in the drain connection. So whilst a containment seal integrity test sounds easy, it often isn't on an installed seal, and more so if the process is actually running, as this pump has to be stopped to conduct this test. We have urged numerous other customers to review their fleets, and some have detected seal failures without them knowing immediately. A refinery in Asia had a 50% failure rate of 138 installed containment seals which were not of AESSEAL manufacture. A UK-based petrochemical plant tested their entire fleet and suffered 70% failure rate. A refinery in the United Kingdom reviewed their fleet and, regardless of the pass or fail result, instantly recognised that they could fail without prior knowledge. They took the decision to implement an upgrade program to replace them with pressurised arrangement 3 dual seals. And then lastly, another refinery in the United Kingdom also followed the same path. Major operators globally have now realised the hidden dangers of not operating containment seals with a Plan 72 installed, and decided to replace them with a phased program of upgrades to dual pressurised seals. In the UK, we have the Health and Safety Executive. They are a government body and a national regulator for occupational health and safety. They don't act alone, and they work in conjunction with employers, trade unions, trade associations, and professional bodies who concentrate on the most serious risks and accidents. They do have legal powers to shut down plants by issuing prohibition notices. I am sure there is an equivalent to the HSE in any of your respective countries. For instance, the United States has OSHA, which is the Occupational Safety and Health Administration, and I am sure there are others like this globally. The incidents which follow were all involving containment seals that did not contain when the primary seal failed and could have been prevented. Failures were from various manufacturers of containment seals and largely surrounded the issue of not applying and supporting them properly, together with general misuse of equipment. I will only elaborate on the two highlighted on the next slides, but rest assured that there have been more than two that we are highlighting here. This was operated with a basic leakage collection system for condensing fluid leakage. So in essence, a Plan 75. The level switch was inactive due to spurious trips over a period of time, and the leakage was also waxy, which led to the level switch sticking. The pump was then run dry for a period of time, which destroyed the inner seal, and when fluid was introduced to the pump, the heat from the seal caused a fire. The containment seal did nothing, and it was not certain if it had failed prior to destroying the primary seal, as it was too badly burnt in the incident. Testing carried out had resulted in the seal seeing over 700 degrees centigrade or approximately 1300 Fahrenheit. If the pump was furnished with a Plan 53B, then the fire would never have occurred, as the seal would have been cooled by the barrier fluid and contained the hydrocarbons. In this instance, the client just manually monitored the interspace between the primary seal and containment seal with a pressure gauge on the daily walkarounds by the site operatives. It constantly read 0, which in the eyes of the operator meant that the primary seal was operating correctly and leak-free. Unbeknown to them, the containment seal had failed a long time ago and was leaking emissions out of the interspace, and this is why the pressure gauge constantly read 0. The containment seal was worn to such an extent that the carbon face had been destroyed and a metal-to-metal contact occurred, creating a spark, and a small localised fire occurred. The main issue here was no Plan 72 employed to monitor the containment seal, which would have led to a high flow and loss of pressure of the buffer gas. This would have indicated that there was an issue and prompted the operative to investigate further, but clearly this did not happen due to misapplication of the correct piping plan. At AESSEAL, we don't believe the dangers of not supporting a containment seal correctly are publicised enough when it comes to pump seals. If we considered tandem dry gas seals for turbo compressors, a leading international compressor manufacturer based in Germany recognised that the outboard seal of a tandem seal could have failed prior to the inboard seal failing due to lack of conditioning and monitoring. They recognised this as unsafe practice and produced a safety paper on the lack of industry understanding back in 2007. The safety paper stated, if the outboard seal is not monitored, it is possible that damage or leakage from the seal is not detected, which means that the backup function is not ensured. This in turn poses the risk of an undetected total seal failure with significant leakage into the secondary vent system and bearings, which could result in severe damage to the compressor. The conclusion is that if both seals are damaged and the outboard seal is not monitored and any damage to it goes undetected, then a potential total loss of containment exists. The paper states this poses a significant hazard to personnel, the environment and equipment. So if this is the case with tandem dry gas seals on compressors, which is by and large an arrangement to design, why has it not been recognised earlier on containment seals with pumps? At AESSEAL, we believe that the same issues are in play. We hope that this week has highlighted this issue outside of our close customer base and leads to an increased level of operational safety when it comes to process fluid containment. Tune in next week for the next session where we consider the total life cost of implementing containment seals, where we demonstrate that containment seals are not as cost effective as they would first appear.